All right. So after we introduce the first part, when you have a basic overview of how your data looks like, and we can move on to the second, which is actually the necessary step, what we term them as data smoothing. Under data smoothing tab, we include several functions, includes smoothing and cleaning the data collects directly from the computational pipelines. And we further want to smooth this data and plot how the smoothened data look like. And we use a cleaning strategy termed as clean data and clean data graph to represent how these data look like after you trimming of some outliers exhibit from the images. The basic principles of smoothing is using three basic statistical regression model to feed the original data. So you click here, you'll be able to see there are three functions called the smooth, spline, Boyce, and polynomial regression. By applying these three different models, also with specific parameters, you'll be able to see how your data was feed accordingly. By using smooth spline function as one example, if you click smaller end knots here, you got a more rough and general kinds of the regression feed. If you use a larger values, it's more likely to reconstruct the specific original errors, values you have from original data. Okay, so we usually would maybe click choosing relative smaller values. And the outlier removal cutoff means how much degree you want to exclude the values which fell out to the standard deviations. So here we're not going that much details. Further, you can visualize how your plants grow one by one by clicking them. So here we have some example like the third plants under the camera A, the RaspiPheno. For some reasons that the phenotypic data does not look very make sense. A lot of noises around. So you can think about if you want to keep it or if you want to remove that, you can clicking the manual selection of plants not included in clean data to prevent this kind of potential noises to your profile of the data. So we can clicking them one by one. So like this forest plant looks good, you should keep it. When scrolling down, we probably have, you see this one for sure doesn't kind of make sense. The plants are not growing very well and you're not expecting to see the size of the plants get decreased. So we should definitely remove the RaspiPheno camera B, the first plants. After this very quick overview, you can clean up your samples with your fingertips, just clicking. The other example where the plants are not growing at all, you just remove it. All right. Okay, so I'm not gonna do each of them, but just want to give you a basic idea. You could just use your mouse to easily, to remove and clean those plants you don't want. Now we click the button called the Smooth and Clean All Samples. So by clicking to the Smooth Data tab, now you'll be able to find your specific plant ID. At specific time points, what's the areas of the smooth? That means this is a fitted value being calculated based on the regression model we selected. Also, the residual means what's the delta between the original data relative to the smoothed data. And there are some sigma and other statistical value you can see. And you are free to download this one back to a CSV if you need more informations for downstream analysis or as a quality check. After that, we can further go to the visualization part for smooth data graph. It's the same problem sometimes that this pops out a little bit slow. But again, here you're able to play around to show the smoothed data by this clicking. For instance, we still want to check under treatment condition how this data look like. We also want to further facet wrap to see if the two cameras performs. I'm sorry, if the rigs or cameras they are look kind of similar by use of facet wrap function. And I'm not going into much details. Similarly, for all the cleaned data and clean data graph serve as same function, and the difference are the clean data are aiming for removal, the removal of all the noises, outliers of the dots, but the smoothing data are gonna keep all these data points, but replace them by the smoothing values.